Hello, everybody. Now we're going to look at, now that we've installed the data analysis tool pack and all that, we're going to look at how do we do our descriptive statistics in Excel. So in Excel here, I have two data sets, A and C, just label them by the columns they're in. And let's say I want to compare them. I want to find mean, median, mode, and all that. Well, I can go about finding them separately. The command for median is average. So I type in equals average and I do an open parentheses and I will highlight the data in column A. So now if I want to compare that to column C, I do the same thing, equals average. And rather than highlighting the data, I know it goes from C1 to C80. So C1 colon C80. And there we can see the data set for C has a slightly larger mean. Again, that command was equals average. Now for mode, the command actually is mode. And we see the mode for data set A is 35. I can do the same thing for data set B and I get 36. That's what's going to be the problem there for data set A. Let me do this. I'm going to take data set C. You may have noticed that the numbers changed when I executed that command. I had data set C in there as formulas rather than as numbers. I randomly generated a data set. So whenever I do a calculation, it's going to recalculate those random numbers. So now they're in there, they're going to stay the same. And then the median, oops, it works the same way. I type in equals median, then A1 to A80, or I could highlight from A1 to A80, and I get my median. And the median of data set C is 36, and A is 32. Now, range is not a command that is pre-made in Excel. You see, I type in range, there's nothing that comes up. So what we have to do for range is we do the maximum minus the minimum. And I get a range of 66 for data set A and 44 for data set C. Standard deviation. Well, it's equals STDEV. Now, it depends on whether this is a population or a sample. We're going to assume these are samples. Most of what we do is going to be a sample, so we use .s. If it was the entire population, we would use .p. So for data set A, the standard deviation is a sample is 9.386, 9.387 technically. And for set C, it's 9.118. If it were a population, it would have been equals stdev.p is going to give us a slightly different standard deviation. It's always going to be a slightly smaller one for a population. Now, the bigger the data set is, the closer the sample standard deviation will be to the population standard deviation. Variance is part of the standard deviation. We can always just get it from that, but we can do equals var. Again, .s or .p is a sample, so we're going to do .s. And so there's the variance for set A. We could find quartiles. We saw that actually in one of our videos for the box plot. Equals quartile. We open our parentheses. We have to enter the data array. Again, that's where we'd highlight A1 through A80. And then we do a comma. Then what quartile do we want? Well, we want quartile 1 if we want the first quartile. If we want the third quartile, we do comma 3 to get the third quartile. What if we did comma 2 for the second quartile, you'll notice it just gives us the median, which is what the second quartile is. So we can do each of these individually using those commands. Equals average for mean, equals mode for mode, equals median for median. Range, we have to do the maximum minus the minimum. Standard deviation, we have to make sure we know whether we have a sample or a population. For a sample, it's stdev.s. For the population, stdev.p. Variance, same way. We have to know if it's a sample or a population. And then our quartiles, using that quartile command. Or we could have done this all at once. Now that we have installed the data analysis tool pack, if we go to the data tab over here, we see data analysis on the very end from our add-in. And what we want here is the descriptive statistics. So we're going to hit OK. Now we have to enter our data. So we're going to click here to enter our data set. This is going to be A1 to A80. Grouped in columns, so that's telling it to stay down the column. The output range, we're going to click there. I'm going to put that right here. Then I have to select. Now I've already selected summary statistics here, so I'm just going to leave that selected. If you don't select anything, it's going to give you an error when you click OK. So summary statistics, hit OK, and here it gives me exactly what I found over here, my mean, my median, my mode. Now this standard E, that standard error, that's something that'll come in when we do confidence levels, confidence intervals later on. It's actually the standard deviation divided by the square root of a sample size. So here, a standard deviation of 9.3868 divided by the square root of the 80, which is going to be about 9. So you can see that looks about right, just over 1. Median and mode are the same. Standard deviation, it's going to default to a sample standard deviation for our descriptive statistics. Sample variance, same as we got. Kurtosis and skewness, those are things we don't cover in this class. That's basically if it's not a perfect symmetrical bell curve or normally distributed curve. The range, the minimum, the maximum, and then how many are there. Now I could actually do both columns at once if I wanted to. I don't have to do them separately. I could actually do descriptive statistics, input. Actually, since they're not next to each other, it might not let me do them both at once, but let me do that. Oops. Oh, come on. See what happens. I'm going to put my output right there, see if it'll do them both. And you can see it actually does do them both. The first column is done. It does calculate column 2 since there was nothing in it. That all comes up zeros. And then column 3 is right there. So this does work better for multiple columns if the two columns of data are right next to each other. And you were able to do that by selecting that grouped by column function here so that it did each column separately. So that's it for findings descriptive statistics using Excel. Not too bad. This is one of the few things that Excel, I think, does better than any sort of graphing calculator or any tool like that, because it's way easier to enter the values in here than it is to type them into a calculator. So with that, if anything comes up, please let me know. Otherwise, we'll see you in our regular scheduled class.